a National Science Foundation project funded for studying the power system and computing and communication infrastructure and how they are interlinked with each other and how one's problem in one can affect the other and so on and so forth. So that's where I learned about all this stuff. So, and the way we studied this is by doing something called co-simulation, and I'll talk about that. And then we'll talk about the particular co-simulator that we designed, which is called Gecko. And then I will show you two examples of application of this co-simulation in order to configure a particular grid and communication infrastructure case. Now, most probably I will have to hurry through this because yesterday in both places that's what happened. So I'm going to say that I will only give you a very superficial idea of what's going on here, and I think somebody here has this slide. So if you want the slides, they can probably provide you with a copy. So in 1997, the US President commissioned this study for critical infrastructure protection, because some of the infrastructure like power system is a critical infrastructure for any nation's security in terms of financial security and also national security. And the idea is that if that critical infrastructure is disabled by a foreign agent, in the US in particular they're worried about the Chinese doing it, then it might be a problem. But what happens is that since the infrastructure, other infrastructures are very closely linked and interdependent with power system, it may so happen that by attacking other infrastructure, you can disable power system, you can disable the banking system, you can disable the water system, or you can disable some other system. So it's important to study like what are the different ways the vulnerability to a particular infrastructure can come in through other means, because all these infrastructures are interrelated. So this particular committee basically suggested that this should be studied, and that's how the National Science Foundation started this program. And so examples of critical infrastructure I already mentioned are some of these are in important critical infrastructures of a country, and oftentimes they are related to each other. And there was a study in CMU that showed this kind of interdependence, and you can see that this interdependence is not very simple, it's very, very complex interdependence. For example, power is related to natural gas is related to transportation is related to the oil infrastructure, electric power is also related to water infrastructure, telecom infrastructure affects all of these things. So this is a very complex interrelationship, and the study that we did was to study the interdependence here between electric power and the communication infrastructure. So as I already mentioned before I started what an electric power grid is. So I already said that India has these 5 different subgrids that are connected with each other. In this case, you have US has 3 major grids, which is the Eastern interconnection or Eastern grid, the Western interconnection, the Western grid, and the Texas grid. Texas grid is disconnected from the other 2 by DC lines, and these 2 are also connected through the mountains by DC lines. So any disturbance, for example 2003 blackout that happened in the northeastern region of US, did not affect the Western grid or the Texas grid because they are connected by DC lines. This is also connected to the Canadian grid and some parts of the Mexican grid as well. So what are the components of a grid? And I already kind of hinted at that. So first thing is generation. So you have various generators, like you have renewable generators nowadays with like wind and solar. You have natural gas-based generators, you have nuclear generators, you have coal-based generators, and so on. And these has to be connected to the load centers. So if you see that these are connected by huge transmission lines. So these transmission lines, you will see if you like drive to remote areas, you will see huge transmission lines like many 100 feet above you, supported by transmission towers. And sometimes you will see substations. Substations are places where all these transmission lines converge and then diverge from there. So substations are one of the places where there are a lot of computerization and embedded computing going on. and then you have power poles and so on. And eventually this comes to the city and population centers, where you have the distribution network, and the distribution network starts usually at the distribution substation. It goes to various transformers, because the transmission usually happens at a very high voltage, like 765 kilovolt or 440 kilovolt and so on and so forth. Whereas in the distribution, your home will be like served at 220 volts, so therefore it has to be stepped down, so there will be a lot of transformers you will see on the side of the road and so on. So these are the three major components of a grid. Now, there are various aspects of smart grid that affects any of this. Like, for example, renewable integration, and how the renewable integration affects the power supply of your locality, or depends on various things, especially power electronics and also the market mechanism. So that's one part of smart grid that affects the generators. The transmission, and our focus has been mostly in the transmission side. The transmission system is also computerized, because the protection systems are digital usually, and the sensors I talked about before, they are all computerized. The control that controls the oscillation and controls the various other issues are also digital, and also the data that you collect through the sensors are actually huge amount of data. They have to be delivered in real time to the control center, so that the control center can act in real time. So therefore, communication is a big part of the transmission system. On the distribution side, there are other issues, like, for example, smart meters. So I think in some parts of India they have started deploying smart meters at your home, so that you can see actually how much energy is being consumed at what time, and also you can see what amount of energy is being consumed by what device, like your refrigerator versus your TV versus your maybe a washing machine. And you can also see the price of power. Although right now in India the price of power is static, like at every point in the day it's the same. But eventually through this automation it will be more demand driven, which means that in the evening when people come back home and do their cooking and watch TV and do washing and everything, the power price will be higher than it will be in the middle of the night and so on. So then you can actually see that through smart meters and decide whether you want to turn off some of your devices at that time and rather do it at a cheaper time. Also, you might actually want to do automate this based on the pricing. You might want to optimize what are the things that you want to turn off and so on. So there is this notion of demand response system. So on the distribution side, there are a lot of things that you can do also which are smart. So when you ask somebody what is smart grid, depending on who it is and what his research area is, you will hear different things. Like you can hear that all about smart meter, or you can hear all about smart relaying, or you can hear all about renewables, integration of renewables in the grid, or you can hear all about demand response. So these are the different aspects of the smart grid. So I already talked about this. So mostly, in generation side, there is this microgrid idea that you might have heard. That is the idea that if you have a colony, or if you have an institute, and you can generate your electricity using solar panels and winds and gas turbines locally and use that, and then if you have excess energy, you can transport it back to the grid and you can get some money back from the utility company. Right? So this is happening very, very frequently in Germany, for example, right now, and some parts of the US. So this microgrid idea is very important, because the prediction is eventually the most of the generation will become like microgrid based, because the renewable will gradually get higher and higher percentage